Okay, students, now we are going to discuss about problems on Coulomb's law. Problems on Coulomb's law. Here in the first problem, what they given, a certain charge q is divided into two parts, small q and capital Q minus q. What is the relationship between capital Q to small q? If two parts placed at a given distance are apart, or to have a maximum Coulomb repulsion force. That means this charge capital Q is divided into two parts. One is small q and another is capital Q minus small q. Right, these are separated by distance how much? These are separated by distance r. How much distance? R. And also they given the repulsion force between these two charges is maximum. Then what is the relationship between capital Q and small q? So let us solve this problem here. So these are the two charges, small q and capital Q minus small q. They are separated by distance how much? R. There is an electrostatic force between these two charges. That electrostatic force F is equal to 1 by 4 pi epsilon naught Q into Q minus Q divided by R square. Here R is fixed, R is constant and capital Q is constant. Who is variable here? Small q. Now here the maximum repulsion force between the two charges is maximum. Then the derivative of F becomes 0 according to mathematics rules. That means dF by dq is equal to 0, should be 0. Why? Because if F is maximum, then its derivative is 0. So differentiation about equation dF by dq is equal to, okay, here what are the constants here? 1 by 4 pi epsilon naught r, these are the constants, bring outside 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught r square d of dq q into q minus q is equal to 0. Okay, so here d of dq q into q minus q is equal to 0. That means by doing the differentiation here, d of dq qq minus q square is equal to 0. Here the differentiation is differentiation of q with respect to q. That means small q. Q minus 2q is equal to 0. Q is equal to how much? 2q. So small q is equal to how much? Capital Q by 2. This is the relationship between small q and capital Q whenever there is a repulsion force between them is maximum. Repulsion force between them is maximum. This is very important problem, most important problem in electrostatics. So now we are going to discuss about another problem, that is find the force on a charge q1, that means 20 microcoulombs, to the charge q2 10 microcoulombs. The positions of charges are given as P1 is equal to 1 comma minus 1 comma 2, P2 is equal to minus 1 comma 1 comma 1, minus 1 comma 1 comma 1. So now let us start this problem. So here what are the charges are they given? 20 microcoulombs and 10 microcoulombs. That means Q1 is equal to 20 microcoulombs, 20 into 10 to the power of minus 6 coulombs. 1 microcoulomb is equal to 10 to the power of minus 6 coulombs. So Q2 is equal to 10 microcoulombs, that is equal to 10 into 10 power minus 6 coulombs. 10 power minus 6 coulombs. The positions of the charges: x, y plane. This is the first charge. Position of the charge Q1 with respect to origin is R1 here. Next, the position of the charge Q2 with respect to origin here. This is R2 bar, position vector. This is R1 bar. Now what they ask here, find the force on a charge Q1. There is a repulsion force between them. Whenever there is a force is acting on Q1 by Q2, at the same time there is a force is acting on Q2 by the Q1 in opposite direction. These forces are equal in magnitude but opposite in direction. So let us draw this force. These are the distance, position of 1 with respect to 2, R12 bar, and this is F12 bar. Force on 1 due to the 2 along this direction. Now already we discussed about Coulomb's law in vector form. That means F12 bar is equal to, we write mod F12 into R12 cap. This is the vector form of Coulomb's law. Both R12 and F12 both are in same direction, so that their unit vectors are same. So here F12 bar is equal to magnitude of first F12. That means 1 by 4 pi epsilon naught Q1 Q2 by R12 square. R12 cap means R12 bar by mod R12. Unit vector, that vector by magnitude of that vector. Next, here what is R12 bar? Here R1 means R1 bar is equal to what they given, how we convert into vector form, 1 comma minus 1 comma 2. That means R1 bar is equal to position of charge Q1, R1 bar is equal to position vector I minus j plus 2k. R2 bar is equal to what they given, minus 1 comma 1 comma 1. That means in vector form minus I plus j plus k. Okay, R1 bar minus R2 bar is equal to what happens here, I minus of minus I, 2I minus 2j plus k. And also we want here mod R12 is equal to, how we write, square root of 2 square plus 2 square plus 1 square. That is equal to what? Root 9. That is equal to, root 9 means 3 square root. So here F12 bar is equal to, what is the value of 1 by 4 epsilon naught? 9 into 10 to the power of 9. Okay. Q1 means what? 20 into 10 power minus 6. Q2 means 10 into 10 power minus 6. R12 bar. R12 bar means what? R1 bar minus R2 bar. divided by r12 whole square into r12. That means r12 cube, r12 whole cube. So f12 bar is equal to right here 9 into 20, that means 180 into here 10 to the power of minus 6, 10 to the power of minus 6, 10 to the power of minus 12 into 10 to the power of 9, r1 bar minus r2 bar, that is equal to I minus 2j plus k, divided by r12 whole cube, that means 3 cube, r12 whole cube, that is equal to 27. That is equal to how much? 27. So here, by doing these calculations, we get what we get here. F12 bar is equal to by doing these calculations, we get 2I minus 2j plus k divided by 15. This is the answer. F12 bar, 2I minus 2j plus k divided by how much? 15. So this is the problem based on the Coulomb's vector form of law. Coulomb's vector form of law.